Let's take a look at this stoichiometry problem, but this one's got a new wrinkle. Alright, notice 2.55 grams of aluminum and 8.35 grams of chlorine gas are placed in a flask, and the flask is sealed. At the end of the reaction, so we're reacting aluminum and chlorine gas. So that means, notice we have quantities of both. We have 2.55 grams of aluminum, 8.35 grams of Cl2. So that means, what is it? Limiting reactant. Ding, 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 limiting reactant problem. So we're going to have to figure out the limiting reactant. But let's see if we even have to figure out how much of something is produced. And the flask is quickly sealed. At the end of the reaction, what is inside the container? Make sure that you write and balance the chemical equation. Be sure to show all work. So it's not asking how much of a particular product. Okay, so all we need to do is figure out the limiting reactant, and then we can answer this question. So first thing, stoichiometry problem, balanced equation. So we know aluminum is reacting with chlorine gas. And when aluminum and chlorine react in this redox combination reaction, hang on here, we know that aluminum chloride is the result. Aluminum forms a +3 ion, chlorine forms a -1 ion. So whenever I start seeing 3's and 2's, I'm balancing now. Start thinking 6, so 3 chlorines, 2 chlorines. The only way I'm going to be able to do it was 6. Let's try that. So now I have 6 chlorines. That means I'm going to have to put a 3 there. So 6 and 6. That's good. 2 aluminums, fix the aluminums. Now, all limiting reactant problems, the way you want to do them, is first figure out how many moles of each reactant you have. So I have 2.55 grams of aluminum, unless you're English, then you say aluminium. And I need to find a gram-mole relationship. So I know, where's aluminum? 26.982 grams of aluminum is 1 mole. 26.982 grams of aluminum is 1 mole of aluminum. And that's what we're doing there. Figure out how many moles of aluminum. Do the same thing for Cl2. 8.35 grams of Cl2. Use our molar mass. 35.453 times 2 times 2, 70.906. So 70.906 grams of Cl2. That's 1 mole Cl2. So let's quickly do these calculations. 2.55 divided by 26.982, 26.982 equals 0.0945 moles of aluminum. And how about this guy? 8.35 divided by 70.906 equals 0.110, let's call it 8 moles of Cl2. So now we have to look at our mole-to-mole ratio. Okay. That's 0. So I have a 2 to 3, so I'm going to say a 1 to 1.5, just to make my a little easier for me to sort this out. So for every 1 mole of aluminum, I need 1.5 moles of Cl2. So if I have 0.0945 moles of aluminum, I'm going to need 1.5 times that. So what do I have? 0.0945 times 1.5. Most of the time we do this in our head, but we can do this 0.141. So I need 0.141 moles of Cl2. Do I have a 0.141? No, I don't. I have 0.118. So that means that I don't have enough Cl2. So my Cl 2 is the limiting reactant. Aluminum is the reactant in excess. So, to answer the question, what's inside the container, we know aluminum chloride is there because the product is always there. And the excess reactant, which would be the aluminum.